A supermarine Spitfire was hailed as one of the most formidable fighter aircraft of World War II and beyond. It was a marvel of aeronautical engineering. It featured elegant elliptical wing design and a potent Rolls-Royce Merlin power plant that propelled it to speeds exceeding 360 miles per hour in level flight. Pilots revered its razor-sharp maneuverability and rugged airframe, which, combined with its broad performance envelope, earned it a place in the annals of military and aviation history. The Spitfire's fuselage was constructed from duralumin formers, intricately shaped for aerodynamic efficiency, and connected by longitudinal longerons, yielding a semi-monocoque shell that was both lightweight and structurally robust. The fuselage skin was made primarily of Alclad, a corrosion-resistant aluminum alloy, with thickness typically ranging from 0.028 to 0.036 inches. Thicker panels were used around high-stress areas, like the cockpit and engine mount. The ailerons, rudder, and elevators remained fabric-covered to preserve sharp control response and feather trim weights. The shape of the fuselage frame varied along its length, transitioning from a rounded oval at the engine bay through a near elliptical cockpit section to a slender conical tail. The frame measured just under 30 feet in length, with a wingspan of 36 feet 10 inches and was 9 feet 11 inches high. To harness the raw power of the Merlin engine without sacrificing agility, the Spitfire adopted its iconic semi-elliptical wing, a near-ideal platform that distributed lift uniformly and reduced induced drag. A wing center section housed the inward retracting undercarriage, which folded neatly into the wing root to increase aerodynamic flow in flight. Radiators and oil cooler intakes recessed into the wing's underside, balanced high-altitude cooling with minimal drag. This configuration was made possible by the upper and lower spar booms, constructed from 5 concentric aluminum square sections nested within each other. This design delivered exceptional strength, capable of withstanding the stresses of combat aerobatics and dive pools beyond 12 Gs, and was key to the Spitfire's incredible performance. The Spitfire was powered by a Rolls-Royce Merlin V12 engine, arranged in a 60-degree V-shape, and was displacing roughly 27 liters. It produced approximately 1,440 horsepower at 15,000 feet, enabling the Spitfire to reach a top speed of about 374 miles per hour and a climb rate near 4,500 feet per minute. The engine was connected to a 2-stage, 2-speed centrifugal supercharger to increase air pressure at high altitudes. Air entered through a carburetor intake located beneath the fuselage, passed through the carburetor, where fuel was mixed into the airstream, then into the supercharger compressor for pressurization before entering the cylinders. This system enabled the Spitfire to extract maximum power from its 27-liter engine. A radiator cooled the supercharged air before it entered the cylinders. The Spitfire was equipped with a 3-blade rotor constant speed hydromatic propeller, measuring 10 feet 3 inches in diameter. It was connected to the engine through a gear set. Blade pitch was adjustable during takeoff. The blades were angled more perpendicular to the aircraft for maximum thrust in low airspeed conditions. In cruise flight, the pitch was adjusted to align more closely with the direction of travel, reducing drag and maintaining efficiency. A 37-gallon self-sealing main tank sat in front of the pilot seat, with a 48-gallon tank positioned above it, and was protected by a bullet-resistant bulkhead. Together, these tanks gave the Spitfire a total range of approximately 1,135 miles, or 1,826 kilometers. A selector valve allowed the pilot to draw from either tank and transferred fuel in flights, providing tactical flexibility for extended loitering or rapid engagements. The Spitfire's armament included 4 50 caliber Browning machine guns, 2 in each wing, each belt fed at approximately 1,150 rounds per minute, with around 350 rounds per gun. It was also equipped with a 20mm Hispano cannon on each wing, each carrying between 60 and 120 rounds. The cannon had a burst rate of approximately 650 rounds per minute. The Brownings were effective up to 600 to 800 yards, while the Hispano cannon could reach about 1,100 yards. Pilots often fired from within 250 to 350 yards to ensure maximum impact during dogfights. Both guns were powered by compressed air, and at high altitudes, the Brownings and Hispano cannons were heated using exhaust from the engine and radiator. A gun camera mounted in the left wing recorded each firing run, while a pitot chip on the wing fed precise airspeed data to the cockpit instruments. Some Spitfire variants were modified with racks to carry up to 500 pounds of bombs. The cockpit featured a distinctively designed canopy with a slightly bulging midsection and a forward panel made of a 1/4-inch bulletproof glass, offering crucial protection while maintaining visibility. The pilot's seat was engineered with safety in mind, incorporating an armored backplate of up to 0.5 inches thick and a 4-point satin harness, 2 lap belts and 2 shoulder straps, all meeting at a central release cone. A seat adjustment lever was attached to the seat for positioning. On the right side of the cockpit is the oxygen cock control for the oxygen tank. Beside it is a sealed high-pressure CO2 cylinder connected to the undercarriage operating jacks, provided for use in an event of hydraulic system failure. Each seal can be punctured using the emergency lever located adjacent to it. The R3002 master switch served as the main power control for the aircraft's radio transmitter and receiver system. The accompanying R3002 push buttons were used to detonate the Spitfire's identification frame or full transponder. Below it is the de-icing tank, containing distilled water and ethylene glycol in equal parts, with a windscreen de-icing cock situated above it. The jettison lever enabled release of the external fuel tank. Moving upward is the undercarriage lever for operating the landing gear, along with a remote contactor. Forward of these are 3 tungsten filament spare lamp bulbs for the reflector gun sights. The signal switch box controls the undercarriage and top lamps, allowing either steady illumination or more signaling from each lamp, or both. The fuel tank pressure switches were used to pressurize the fuel tanks, preventing vaporization and ensuring consistent fuel flow at low atmospheric pressures. And the kill gas primer was used to prime the engine. On the left side of the cockpit are the automatic boost control lever, the air screw control for the propeller pitch, and the throttle. Positioned above these is the electrical control unit. A Type 45 footage indicator camera is fitted on a wedge plate for support. The aperture switch allows selection of either one of 2 apertures. One of 2 cockpit floodlights is also located here. The elevator trimming tab handle controls elevator trim, while the radar trimming tab controls radar trim. There is a main switch for the cine camera and a pressure head heater switch used for heating the pitot tube. Below these is a fuse box for the electrical components. The radiator lever controls the flap of the radiator. From the lower left of the instrument panel are the magnetos for ignition. To the right is the brake triple pressure gauge, which measures air pressure in the pneumatic system cylinders. The elevator trim indicator shows the position of the elevators. Above it is the electrical undercarriage position indicator with a clock beside it. A standard pilot oxygen regulator unit shows the remaining oxygen in the tank and the flow rate. Positioned above it are the flap control lever and the navigation light switch. At the top left of the central instrument panel is the airspeed indicator, which measures airspeed using air pressure from the pitot tube. The artificial horizon indicates ground angle relative to the aircraft. To its right are the rate of climb and descent indicator and the altimeter, which shows altitude. The directional gyro provides heading information, while the turn and bank indicator assists the pilot during turning and banking maneuvers. The engine instruments are grouped on the right-hand side of the panel and include a fuel pressure warning lamp, voltmeter, and generator switch. Below these are the engine speed indicator, fuel pressure gauge, oil inlet temperature gauge, radiator outlet temperature gauge, and boost gauge. A fuel content gauge and push button are mounted at the bottom right of the instrument panel. This gauge shows the content of the lower fuel tank, but only when the button is pressed. Above the panel is the Type 1 Mark II reflector gun sight, which is activated by a dedicated switch. It projects the targeting reticle directly onto the bulletproof forward glass. Below the instrument panel are the compass for navigation and the fuel mixture control located beside it. The rudder paddles, attached to a shaft, control the aircraft yaw. The central control column operates the aileron cables for roll and the elevator push rods for pitch. The control stick operates the ailerons and includes a trigger to fire the guns, as well as a camera switch for recording. Behind the control stick is the parking brake lever. Behind the pilot seat are the oxygen tank, pneumatic control tanks, wheel brakes, and the battery, along with the identification friend or full box. In all, over 20,300 Spitfires of every mark rolled off British and Commonwealth production lines, making it the most produced single-seat fighter in history. From Merlin-powered Mark IIs through Griffin-driven Mark 16s, continual refinement in engine, armament and aerodynamics kept the Spitfire at a cutting edge from the Battle of Britain right through the dawn of the jet age. It served with the Royal Air Force and half a dozen other firearms, finally retiring from the frontline service in the mid-1950s.